Next, we'll be hearing from Tongzhu Meng about why bitter matters.
As the most popular drink in the world, I think we are all somehow familiar with coffee. So let's get a quick show of hands before we begin. Please raise your hand if you don't like coffee. Raise your hand if you like coffee only when there's enough sugar or milk. Raise your hand if you like your coffee black. Okay, as we can see, our preferences in coffee are vastly different. And it isn't just about coffee. The same thing also applies to vegetables that are healthy but quite contentious in terms of taste, such as broccoli, Brussels sprouts, and kale. What's the one thing all those foods have in common? They all taste bitter. Well, you may think, nah, they don't taste bitter to me. That's because you're less sensitive to bitterness. And this is the result of different genetic makeup in our bitter taste receptors, which have led us to have different sensitivities towards those bitter tasting compounds in those foods I just mentioned. Currently, we know that we can sense bitterness in our by the bitter taste receptors in our oral cavities. But there could be other genetic variations in other genes that we haven't discovered yet. And my project is to figure that out by conducting a genome-wide association study that aims to uncover novel genetic variations that are associated with bitter tasting food preferences. In order to do that, I used the current data from UK Biobank. Genetic data were collected through a usage of microarrays, which are tiny plates but can assay around 800,000 genetic variations in the human genome for several participants at once. And this was done for over 120,000 participants. They were also invited to complete a questionnaire which asked them to rate 144 food items in the degrees of liking. And then we will pick some well-conceived bitter tasting food and then construct a score in the terms of in the degree of liking they have rated. And then I will run millions of statistical tests to see if every single genetic variation is associated with the score we have just created. The results will also be replicated in the UK Biobank or other big national dataset to see whether those genetic variations we have identified are associated with the bitter tasting food intake. From there, if the associations are confirmed, we are very confident to say that the genetic variations we have identified are associated with the bitter tasting food preferences. Therefore, it will allow us to further explore the role of genetics played in the process of bitter food liking and food choices. Thank you.